Higher Tier Unit 3 Section 2.1 deals with angles and parallel lines. Now the whole chapter is about angles and areas, so they've got a lot of the foundation level stuff that took a couple of chapters and they've sort of lumped it into one and done less of everything. So got to look at the foundation videos just to get your foundations up to scratch. Right, so we're working on an EasyJet wing there, so just hold tight in case you fall off and drop down a mile onto the floor. Now this is question 5. It says calculate the size of the angles marked with letters. Let's get on to that. So what have we got here? Let's start with A. Well, A is going to be 105 straight away because it is vertically opposite the 105 shown. So that's that one done. What do we got here? These are parallel lines, so straight away you can see the 68 and the B are alternate angles. So 68 and B are the same, so B is 68 degrees. Is that alright? C, very straightforward. You can see that it's on a straight line with the B, therefore that's going to be 180, take away 68, that will give us 100 and something, 112 degrees I believe. Yeah. 70, 80, very good. Now we do question B. I like question B. This is a classic question. 63, 74 and D. They seem unrelated unless of course you go and do this. If you continue this parallel line here as follows, you can see that this part of the D angle must be 63 because it's alternate, and this part of the D angle has got to be 74 because it's alternate to the 74 shown. So essentially D is going to be 63 plus 74, two parts of the alternate angles shown joined together, so 137 degrees. I make that. C, I've got to work out 1, 2, 3, 4 angles, and I've only got one angle in the question. Very good. Well, let me just start with this 95. If that's 95 and this is a straight line, then this is going to be 85 degrees. 85 plus 95 makes 180. That's that. Therefore P is going to be 85 degrees for the simple reason that it is corresponding to the 85 degree angle that I've just calculated. Parallel lines going this way, therefore Q straight away is going to be 85 degrees because it is corresponding to the 85 degree calculated on this side. S is on a straight line with Q, so S is going to be 180, take away the 85, and that will leave us with 95 degrees. Fair enough. And R, well that's beautiful, that's alternate to the 85 degree I've just calculated for Q, so R is also going to be 85 degrees, it's alternate. I suppose I should have written this for all the ones really, but I'm not going to do that. So anyway, 85, Q and R are alternate, so 85 degrees because it's alternate to Q degrees. Alright, now question 6, work out X and Y. Oh fine. Looks terrifying, doesn't it? Parallel lines, yeah, I think I've got that. Study, parallel. I think if that's 65, then so is that 65 degrees because they're corresponding angles. Parallel line, one cut through both parallel lines. So if that's 65 and these two lengths are the same, it's isosceles, this is also 65 degrees. So let's just work out Y first because I'm operating in this direction. Well, here we have a straight line. So Y is going to be 180 degrees. Take away two lots of 65. Is that alright? To give me the leftover gap for Y. So let's grab a machine because I can. What's that? 130 from 180. That's going to be 50 degrees. Check again. 180 take away 130. 50. I'm happy with that. Isosceles triangle. Here we go. I've got 265 and the independent angle on its own. So I've got 180 degrees. Take away two lots of 65 again. It's a different storyline. Don't assume it's the same as that. It's 265s. Take away from 180. This time it's angles inside a triangle, and that will still give me 50 degrees. Is that all right? Now, what have I proven? I mean, I could have worked it out from Y anyway. I mean, look, if Y is there and X is there, then X and Y are in fact alternate angles, aren't they? Because look, parallel lines cut through with this one line here, therefore Y and X alternate angles. So that's another way I could have done it. Maybe I should have done it the most economical way, but Sorry, I didn't see it. Right, what's here? Parallel lines again. Right, I can see this one. If that's a cut through this pair of parallel lines, then these two x's come to 122. So these two x's come to 122. Getting glitchy. 122. So a single angle x is going to be 122 divided by 2. That's going to be 61 degrees. So 61 degrees, 61 today. Right, so let's work out y. So let's have a y is on a straight line with these two x's. So y is going to be 180. Take away the two x's, which is of course 122. That leaves me with something. Machine, quickly, rescue me. 180 take away 122. Doing 58 degrees. I could have done it, come on, but this is unit 3 and I'm working at home and I need all the help I can get. That will do. That's the hardest angle ones that I've got. Nothing beyond grade C. It's barely touching grade C really. It's not higher, but I thought I'd give you something to look at and to revise your year 7 higher work, which is what we did back in year 7 if you were here, if you did the higher course. Certainly should have been able to manage that from year 8 onwards, but anyway, year 7's when we do it, and that's good enough. I'll sign off now.